This is a very quick walkthrough of the second exam solutions. If there is anything here that you do not understand, please don't hesitate to stop by my office and come and chat about either the work that you did or just the content itself that you have a question about. So let's go ahead and get started. The first question, trying to max or min values of a function. The function is called f of x. The student finds that x equals 4 is a critical value of the first derivative. What would her next step be using the second derivative test? And the key is that not only is 4 a critical value of the first derivative, but they want to use it in the second derivative. Yes, you could create a sign chart for the first derivative, but remember that first derivative sign chart is going to give you increasing, decreasing mins and maxes. This student wants to use the second derivative test, so that means they're going to need a second derivative in in order to do that. And so you could go ahead and substitute into the original function. Substituting it into the first derivative isn't going to help because it's a critical value. It's going to be 0. And so last choice is going to be D. For the second question, Harry's using the first derivative test. Here, look, it's labeled. And this is what values that student determined. What can he conclude? Well, we know that when the first derivative is negative, we have what the student put down was downward slope. And here, increasing slope. So here is going to be a relative min. And the relative min is going to occur at 2. So it is C. For number 3, this function is increasing. So the y values are getting larger from left to right. It is concave down, concave up, remember, looks like this. So increasing and concave down, A is the answer for number 3. For the next few questions, you need to use the graph that's sitting here on the right. Let's go ahead and look at that graph before we look at any of the questions. This is the graph of the first derivative. Now, we don't usually see it like this, so let's translate it to our sign chart of a first derivative. This derivative is 0 at -6, -3, -1, and 5. Here, those values are marked. That is where it is 0. Those are the critical values. Those are what go here. Now, to get the positive and negatives, we are not looking at slope of the lines that are occurring on this graph. We're looking at the values, the y values, because this is the first derivative. And so the first derivative is positive from -6 to -3. Less than -6, it's negative. From -3 to -1, all the y values for the first derivative are negative, so we have a negative here. From -1 to 5, all the y values of the first derivative are positive, so we put positive. And then greater than 5, they remain positive because it comes down and bounces off. So we can ignore this and look at this for a second and say we do know decreasing, increase, we have a relative min here. Up, down, relative max, down, up, relative min. Oh, and the sign stays the same. We don't know anything yet about what's happening at 5. Let's go ahead and develop a second derivative sign chart from this graph. Remember, when we had a function itself, we found when the first derivative is 0 by looking at the peaks and valleys for the horizontal tangent line. So the derivative of any curve is going to be 0 when you have a horizontal tangent line. For the first derivative curve that is here, the second derivative is 0 at each of these peaks and valleys. So we have 1, 2, 3, 4 of them. So here at -4, second derivative is 0 at -2, second derivative is 0 at 1, and at 5. So mark each of those. Now what we have to look at is not the y values of the first derivative here, so that we're not looking at first derivative values. We are looking at the slope of the tangent line to the first derivative, which is the slope of the second derivative. So here, from -infinity all the way to -4, it is positive because they're all positive tangent lines. From -4 to -2, downward facing, negative, so we have a negative there. From -2 all the way to +1, all of these lines are positive slope tangent lines. And then from 1 to 5, negative slope tangent lines. And then 5 to infinity, positive slope tangent lines again. Once you pull that information off, we can then look at the second derivative to say concavity is facing up, facing down, point of inflection, changing concavity, point of inflection, changing concavity. So we have lots of changes in concavity shown here, and therefore points of inflection. So let's go look at these questions now. They're telling you that the first derivative of -3 is 0. That's just to remind you that here, when you put -3 into the derivative function, which you don't know, you only have the curve, that it's going to give you a 0 value. So now we are examining what happens at -4. -4 lies in this interval here. In this interval, there are no critical values for the first derivative at -4. Let's jump to the second derivative. There is a critical value for -4 for the second derivative, and concavity changes there. So therefore, there are no min and maxes because it's not a critical value of the first derivative, but it is a critical value for the second derivative, and concavity changes, therefore it's a point of inflection. For number 5, which of the following is a critical value for the first derivative? Well, here are our critical values. -4 is not there, -1 is, 0 isn't, 3 isn't, so the answer is B. For number 6, what of the following best describes what happens at x equals 5? Well, 5 is sitting on both of these derivative sign charts. Here we can see it's increasing, original function, because of the first derivative values there. And now on the second derivative, we see a concavity change there. So let's look. F has a critical value that is neither a max nor a min. That is true. It's a critical value, but it's not a max or min, so we do get A. F has an inflection point. Second derivative is showing you that, so B is true. Well, that means that it is both A and B. So the answer to this one is D. If you got number 4 or 6 correct, you got an additional 3 points. If you did not get either of those correct and they were incorrect, you did not lose points. Let's go to number 7 for this one. Which of the following is a critical value of this? To find a critical value, you need the derivative and then set the derivative equal to 0. And so this is the first derivative is 2x minus 2, and then set it equal to 0 and solve it, and you get 1. There's only one critical value for this function. It's at 1. So find the 1, and you get A. Number 8. Which of the following statements about a function is true? Well, for this guy, you're going to want to do some derivative work because we're talking mins, maxes, and inflection points, and the only way to know what's going on is to take a derivative. So the first derivative is going to be 3x squared minus 12x. Go ahead and factor it, set it equal to 0, and you'll see you have critical values of 0 and 4. This is the first derivative sign chart. And so checking each of those and what's happening with the values, we can see that at 0 there's a relative max, at 4 there's a relative min, and so at 0, it says local min. That is not true. There's a max there. We do get this local min at 4 because we have this occurring, comes down then goes up. And so we can go and check to see if f of 4 is -20, and the student did that, and you do get -20, so C is the answer. You know, is there an inflection point at 4, -20? Well, you could do the second derivative. The second derivative is 6x minus 12, which is 6 times x minus 2. The only critical value there is 2, and so we need to use the second derivative to find inflection points, and 4 is not a critical value, so therefore we can't do anything with that. Let's look at number 9. Find the absolute value on this interval. To do that, you want to first see if there are any critical values of this function within that interval. So go ahead and take the first derivative. First derivative is 8x minus 2, which is 2 times 4x minus 1. And the critical value is 1/4. And 1/4 does not fall in that interval, so we don't have a critical value. That means all you have to do is check the endpoints, find the y values, and when you do that, you find that the largest y value you get is 15. Section 2, 10 through 14, all you're doing is taking derivatives. Power rule on this one, bring the 3 down, you get x squared. For this guy, rewrite it algebraically. Bring the negative 3 down to get negative 6, subtract 1. Power rule again once you rewrite it. Then for the next guy, instead of using the quotient rule, and some of you keep going to the quotient rule when you don't have to, this is really 4/3 x to the 5th. And then when you bring and take that derivative, the 5 comes down times the 4 is 20 x to the 4th. So 20x to the 4th over 3. And yes, that is this, and you can simplify it. But if you just simplify first, then go in, you can get it right away without it having to have some more ugly look to it. Quotient rule. Ugh. Don't do that unless you have to. The next one, go ahead and rewrite this. This is 3 times the square root of 1 minus x, so bring the 1 minus x and raise it to the 1/2. That's how we rewrite our square roots. Then the 1/2 comes down, 3 times 1/2 is 3/2. Keep what's inside, subtract 1 from the exponent to get negative 1/2. Chain rule out the negative 1. That's one of the more common errors, was to forget the chain rule that value out. You can leave this like this, you do not have to simplify. For the next one, you're going to go ahead and rewrite it. When you do, you get negative 2, and then x to the 1/2 from the denominator, and you move it up, so it becomes x to the negative 1/2. Now take the derivative. Bring the 1/2 down, negative 2 times negative 1/2, positive 1. Subtract 1 from 1/2, negative 3/2. And you can chain rule out, because most of you have been trying to do that every time. This guy's chain is just 1, and so you get the same thing, whether you have this 1 here or not, and this 1 here or not. And the last page, the first problem is you have price, and you have cost, and you have to find revenue. And so for the first thing you want to find revenue is going to be quantity times price. What's the quantity? X. X suits times the price, this. So just multiply X times that to get this function. Now find the formula for profit, and for profit is revenue minus cost, and you had to actually find that. You couldn't just write, oh, profit's revenue minus cost. You have information. You had to actually get a function for that. And so revenue, you just take this guy and rewrite him. Minus, don't forget your parentheses. Sorry, this student's work was lost off the side. And so minus, and then you just rewrite this entire function here, and then you're done. How many suits must be sold to maximize profit? And so what you do is enter this into your calculator, and then you can use your second calc and look for max button and do left and right bounds to find that. If that does not make sense to you, you can come and ask me and I'll show you how to do it. Much easier with a calculator in front of us. For the next part, you're given a function and you need to use the first derivative to find our relative extrema. Don't forget your sign chart. And then use the second derivative test to find all extrema. Notice it says a single answer for both A and B. The reality is, if you use the first derivative test or the second derivative test, you are going to get the exact same relative extrema. So you shouldn't have 2 answers here. You should have 1 answer, and it is supported by both of these solutions. So the first derivative test, take the first derivative, factor it, set it equal to 0, critical values. Put the critical values on your first derivative sign chart. And then check whether you had positives or negatives. Many students write pluses and minuses here. If you do arrows, that is perfectly okay. It means the same thing. It also helps some students remember that this would then be a relative max. This would be a relative min. So there's a relative max at -2, a relative min at 12. Yes, you have to say which is which. And then go and find that y value. You have to actually find the y value, because this is saying that there is a relative max of -64 when x is -2. This is telling you there is a relative min of -1436 at x is 12. Now the second derivative test versus a sign chart of the second derivative. The second derivative test itself test the critical values from the first derivative into the second derivative. There's no sign chart. You're just substituting in and looking at concavity. So you take the -2 and the 12 critical values from the first derivative, substitute it into the second derivative. This first one's a -42, so you have a concavity facing down, which means that you have a relative max at -64, which is this. This is not, notice, sorry, this is the same as this. It's not contradicting it. That's what I was about to say, sorry. And then for the next one, f double prime of 12, that's the other critical value. You get +42, meaning it's facing up. So you get a relative min here. Go check that y value, and it's the exact same thing you got for the other one. So again, the same answer for part A and for part B. Now to find inflection points, you have to check concavity. Concavity to us means second derivative. So you have the second derivative. Find the second derivative's critical value. Points of inflection are going to occur at the second derivative's critical values, not the first derivatives. So go ahead and do a sign chart for the second derivative. Yes, you do need to show concavity. Here, instead of arrows, though, this guy is facing down here. The concavity is facing up here, so you do have to change that slightly, and then and not have these arrows. So these curves should be up here or just down here. Don't have those lines. The lines we just use up here at the first derivative. And so since the concavity changes, we have a point of inflection at 5. Now you got to go find the y value, go back to the original function, and find the y value. Let's look at the last question. Find the absolute extrema of the given function on -1 to 1. So -1 to 1, we have x and y, -1 and 1. So the question becomes, are there any critical values between those two that we should check? Critical values are -2 and 12 from the first derivative. They do not fall within here, so there are no other critical values to check. You just use the endpoints. And at 1, you get -226, and -1, you get -84. And so on this interval, those are the absolute max and mins. -84 is a larger number on the number line than -226. I know that 226 is bigger, but because they are negative numbers, -84 is a larger number on the number line than this. And so you get an absolute min at this, so you see an arrow here, they should be switched. That's what this guy, my note is. Absolute max at this and an absolute min at this. So that's it. Hope you're having a great day. Come see me if you don't understand any of this. Take care.